Alright folks, so another question that we have here today is based off another transition piece where we can see it says we were given a structure here. It says the projections of a sheet metal transition piece are given, the elevation, obviously the plan, and we've got the pictorial view down here, and it says complete a one-piece surface development of the transition piece. So straight off what we're going to do is we're going to start off by just labelling the structure. So on the ground here we can see that we have a square base at the bottom of it. So if I label that 1, 2, 3, 4, and then at the very top you can see we have this rectangular structure here. Now if we actually looking at the rectangular structure, I'm going to label it here 5, 6, 7 and 8, and anything I label in my plan I should also label in my elevation. So 1 and 2, 1 being at the back, 2 is at the front, 4 is at the back, 3 is at the front, 8 is at the back, 7 is at the front up here, and then 5 is at the back, and 6 is at the front. Okay, so just looking at that straight off, before we do any surface development of it, what we're going to actually have to do is we're going to have to just work out our own true lengths. And to be able to do the true lengths, just looking at it straight off, I'm going to actually work out a couple of them if I can. So looking down on my base, all of these here, 1 to 2, 2 to 3, 3 to 4 and 4 back to 1, every one of them is a true length, because we can see that they're all sitting down on the ground. So if they're all sitting on the ground, when we look down at it, they have to be true lengths. Now 5 to 6 is also a true length, as is 7 to 8 in plan, because in our elevation we see them as a point view and they are running obviously parallel with the ground. They're obviously going into the page in that direction, so they are. So 7 to 8 would be going straight in like that, and because of that, that means that this is parallel with the ground, so it's a true length. Now in our plan view, the distance from 7 to 8, or 6 to 7 and 5 to 8, or whatever, however you want to call it. Now in our plan view, this distance here, which is this edge, in my plan view, this is not the true length. It is only the true length in my elevation view. And the reason for that is because when we look down on top of the plan, this might appear, if we didn't have the elevation given to us, it might appear that that was literally just a flat piece and it wasn't inclined at any angle. Whereas we can see in our elevation, it actually does have an angle and it rises. That means because it is parallel in plan with the XY line, which one of the principal planes, that means our elevation line is the one that is the true length. So our 7 to 6 true length is actually up here, and our 8 to 5 is the exact same. Okay, now after that what we have to work out is, so that's all the outside lines taken care of and the inside lines using the elevation and plan. Now what we have to take care of is the 4 lines that are connecting them from the top down to the bottom, down to the base. Now to find the true length of 5 to 1, how I would do that is I'm going to use the cones principle, where 5 is the apex of a cone. So if I was just to join that up to the very top, 5 would be the apex of the cone up here. And obviously when we look down on top of the apex in plan, we would see down the bottom, when we look down at the cone, we see a circle. So if I wanted to find the true length from 5 to 1, which is going to be the same as 6 to 2, all I'm going to do is, from 5 to 1, I'm going to use the extreme generator method, because when I look straight at a cone, I'm going to see a triangle, and that triangle will be the extreme generator on the outside. So from 5 to 1, I'm going to rotate it, taking 5 to 1 as my radius. I'm going to rotate that around, and we can see the new position of our 1 is here as the extreme generator. But what I'm actually going to do with that is just project it up, and obviously my original 1 was over here. It has just been rotated around, and when we rotate it in plan, it just moves across, straight across the XY line in our elevation. So that line there, I'll just put it in a little bit heavier. That line there is my true length for 5 to 1 and also 6 to 2. Okay, so that's very important. Now if I wanted to find the true length for 3 and 7 and 4 and 8, now they're not going to be the same as 5 and 1. Now they might look like they're the same in plan, but we know that they're actually not, and the reason for that is because we can see that 5 up here and 6 were a lot higher than 7 and 8. So to find the true length of this, we're going to actually just use the same method, just on the opposite side, taking 8 to be the apex of our cone. So the apex of the cone, if I just marked it up there, that's where it would be. The exact same method though, it's probably going to have the same radius, and it does. And from there, obviously project up. Another way I could have done was I could have just taken the radius, which was here, and I could have literally come to this point and just marked it out. It would work out the exact same. Just put it up. There we go. And now I have a true length. Once again, just put that in a touch heavier. And that is my true length for 4 to 8 and 3 to 7. So it's very important we just label so we don't get too confused. Now, at this point, I actually have the true lengths of every line that I need. Okay? So at this point, we can actually get it started, the surface development. So what I'm actually going to do is I'm going to take my point 1 as my start point, and I'm going to start it right about here. That's my point 1. Okay? Now, if I wanted to get from 1 to 2, I can take that straight as a true length. So at 1, I'm going to do a straight line down, and I'm going to take my distance from 1 to 2 as a true length. Right there. I can take that straight off the base. I have to extend my line a little bit further. There's my 2. Okay. Now, the true length from 1 to 5, I have it up here, I found that. And the true length from 2 to 6, I also found that. So, let's find them. Taking that as my true length, from there to there. And from 1 to 5, so somewhere out here, along that arc is going to be 5. And the exact same from 2 to 6. Now, at this point, we have a little bit of an issue, because along this arc, somewhere along that is going to be 0.5, and along this arc from 2 is somewhere meant to be 0.6. But I cannot definitively say exactly which one is which. Okay? So, like a previous question that we did, what we're going to use is the triangulation method. And the triangulation method is when we have a plane surface. So in this case, our surface is 1, 2, 5, 6, or 1, 2, 6, 5. And what we're going to do is we're actually going to just split it up. Okay, and then we're going to get a true length. So the way I'm actually going to split this up is actually from 2 to 5. And you can see when the reason they call it a triangulation method is because what I've done is that plane surface there, I've actually split it up into 2 triangles. And we can see we have a triangle 1, 2, 5 and now 2, 5, 6. So what I'm going to do now is, with 5 as the apex of a cone, I'm now going to get the true length from 5 to 2. Okay? So the exact same method as we have previously done. From 5 to 2, I will rotate. Might have to extend out my line a little bit further in a minute. So 5 to 2, I'm going to rotate up to somewhere about there. And I'm going to just move up my t-square till it goes out to there. And at this point, project it up. So my 2 has basically moved out here. That's my stream generator of a cone. And once again, join it up to the apex, which in this case is 5. Put that in a little bit heavier. And this now is my true length from 5 to 2, or 2 to 5, whatever way you want to call it. Okay, now that I have a true length from 2 to 5, or 5 to 2, I'm going to take that on my compass, right there, and because it's going from 2 to 5, that means from 2, I can go across from 2 to cut the 5 arc. And where the 2 arcs cross each other has given me my definitive point 5. And at that point there, I can now join that to 1. Now, if I was to do another cross section here, or a line from 1 to 6, that'll actually work out to be the same as the 2 to 5. However, at the 5 one, I also have the true length from 5 to 6. So there is a number of ways we could actually do this. It's just recognizing which one we want to use. So I'm going to take the true length from 5 to 6, and on point 5, mark it. And there I have now found point 6. And that then will be the first phase of my surface development. Okay. And what we're going to do is we're going to continue on in that sequence. Okay. So, starting off, now we've done this whole phase here, now we're on to this phase. So I'm going to start with 2 to 3. Just this distance here. Okay. And somewhere out along there, along that arc, is my tree. How would I find that tree though, is the question. And one way we could find it is, I don't know exactly along that where it is, but what I could do is from 6 to 3, I could do another triangulation method. Because I do already have the line 2, 6, so I could find the true length from 6 to 3. At this point, what we have to do is we have to find the true length from 6 to 3, because I've got 2, 6 as a definitive line, and what I need to do is I need to find the exact point of 3. Okay, so to be able to do that, what I'm actually going to do is I'm going to use, in this case, because 6 is the tallest point I have here, and 3 is actually on the ground, I'm going to use the 6 as the apex of my cone to find the true length all the way to 3. So if 6 is the apex of the cone and we can see 3 here, what I'm actually going to do is I'm just going to rotate 3 down in plan, essentially creating part of my cone. Where it hits here and it comes across from 6, goes straight up to the elevation. 3, which was originally here, has now just moved out to here, and I can find, if I join that to 6, there we go, and once again just put that in a little bit more clear. That is my true length from 6 to 3. So I can now take that distance there to there, and I have a 6 already, and I have to extend out my arc a little bit further from my original 2 to 3. There we go. I have found the exact positioning of 3. So there's many ways you can actually complete these questions. It's just a case of working your way around them. Now, there's my, and I've added, just for actual understanding purposes, as you can see here, I'll just put in the line, that was the true length. And remember my original one, the 2 to 5, was this one. Put him in as well. Just helps us understand it a little bit better. Because you can see so far we've done 1, 2, 3 triangles, and I've got 1, 2, 3 triangles here. Now I have to find my definitive point, 7. Now, have we got that as a true length yet, from 3 to 7? Yes, we do, and we have it right here, because it was the same as, if you remember when I worked it out earlier, from 4 to 8. So, to be able to find my exact positioning of 7, I'm going to take the true length from 3 to 7, which is this guy here. There we go, put it on 3, and somewhere along there is my arc for 7. Now, what I have to also do is I have to get the true length from 6 to 7, because 6 is the other point, and I told you at the very start that's the top line up here, from 6 to 7. Take this distance there, and at 6 I'll cut across, and there we go. So there is my 7. Join all of that up. Now I'll just try to make it a little bit clearer now, because this would actually be a fold line. Now, just have it in a little bit there, and what we can see is obviously I've got my two fold lines, I've got another bit to come out here and another bit possibly, and we can see actually so far we actually have 4 triangles, 1, 2, 3, 4, and look, I've got 4 up here, 1, 2, 3, 4. So with that in mind, we've completed this face here, now we're on to this face, and so far I've already got the line from 3 to 7. So straight away I'm going to take a couple of true lengths. First one I'll take is from 3 to 4, it's right here. Somewhere along that arc is going to be my 4, and I've got another true length from 7 to 8. Same thing at 7. Somewhere along that arc is going to be my 8, and it's just a case of working out which one it is. Now, once again, I don't know exactly where along this arc is my 4, or this one where is my from 7 to 8. So what I'm going to use is I'm going to use the triangulation method once again. Now, if this whole thing was symmetrical, you might think that the 2 to 5 would work from 3 to 8 over here. It doesn't, because as we know already, this section here, in comparison to this section is actually longer, because we can see in our elevation it's a longer face up here, and this is a shorter face. So what we're going to have to do is we're going to actually have to find a true length now from 3 to 8. Once again, just using the exact same method as we've always done. So from 3 to 8, I'm going to rotate it around. And there we go. Just bring it up a little bit further. There we go. Check that up. 3 was the apex of the cone. Now, 8 was the apex of the cone. 3 is just literally rotated around out to here. Okay. And at this point, I now have another true length, and that's the true length from 3 to 8. Okay, now I can take that true length from 3 to 8, which is here, and at my point 3, find it right there. So there's my 8. So we know 8 joins up to 7. And what I've got to do, I'll actually join the 3 to 8 once again, put in the triangulation line, and now I have to find my 4. So I need the true length from, to find my 4, I need the true length from 4 to 8. And oh yeah, my 4 to 8 was this one here. Put him in originally. Right there. And 4 to 8 was, I had the 8, yes, here we go. So there's my 4. Just get confused sometimes as well. So there's my true length. There we go. Now we're on to the last face of it here. So once again, 4 to 1, I'll take that as a true length. There's my 4, working back around to 1. Somewhere along that arc is going to be my 1. And 5 to 8, which is this line, but the true length is actually up here in my elevation. And going 8 to 5, so somewhere out along that arc is going to be my 5. Okay, and now at this point what we need to use is another triangulation line, and in this case I don't need to work it out, because the 3 to 6 would actually be, if we use axial symmetry and flipped it over, because this face is the same as this face, will be the same as the 4 to 5. So just putting it in. The 4 to 5 is the same as the 3 to 6, so my original 3 to 6 was actually this true length that I found here. We can see that I got a little bit messy up here. You might actually lose the image inside it, but that was the original elevation. It's just I have a series of obviously true lengths found. So as I said, 3 to 6 was this guy, which is the same now as my 4 to 5. So at my 4, what I have to do is 3 to 6, 4 to 5. Oh yeah, over here. There we go, because I'm cutting through that line. And there is my 5. There's my 8 to 5. And now I have to find my number 1. So I'm taking the true length from 5 to 1, which was over here. There we go. Take that true length right there. And at 5, I'm going to join that in here. Obviously need to extend out the 4 a little bit further. There we go. And at that point there is my 1. So right now, just going to finish it off. And just for understanding purposes, as you can see there, all I did was I put in my last triangulation line. Now, question was a little bit trickier in the sense that while the shape might appear quite maybe symmetrical down here, we can see in the elevation there was various different true lengths. And it was all because obviously this edge up here was tapered up at a much higher height, whereas this one was obviously much lower. So we had different true lengths for 4 and 8, which was the same as 3 and 7 in comparison to 1 and 5 and 2 and 6. And then obviously our triangulation lines would have worked out different from 2 to 5 also than 3 to 8. So, but it's just a case of recognising and how you work around it and what true lengths we need to be able to complete it. You could use a different triangulation line for every surface if you want. It's just trying to be able to work out the ones that are best suited to ourselves. We could see obviously when we did this one here, 3 and 6, that was the same as the 4 and 5. And it's just making sure that obviously along the way I might have actually made a mistake if I hadn't them previously labelled. Okay, so I hope you found that question helpful there, guys. Very useful terminology and things inside that they are all about finding true lengths and then completing a surface development. Okay.